Welcome everybody. My name is Ulrich Pfeiffer. I'm with the University of Wuppertal and I'm going to present to you what we are working on in the Institute for High Frequency and Communication Technology, which is called IHCT. Now, we are located here on the ground floor of the building FE at the campus Freudenberg. And our main research here is focused on what is called the Terahertz region, which is the transition region between millimeter waves and submillimeter waves, shown here in red, between 100 gigahertz and 1 terahertz. This region is quite interesting because when you look at the attenuation of electromagnetic radiation in atmosphere, which is shown here in this chart, you see that there are some unique interaction between gases like oxygen or water, and this is due to the rotational and vibrational resonances that you have. And this points towards interesting sensing applications already, but also for communication. This frequency range is quite interesting because it gives us a lot of bandwidth, which is important for high data communication throughput. Now, we can divide our research into 4 areas, which is shown here. One of the most important ones probably is the devices and circuits research area, because we base a lot of our activities on the results of this research. And then we bring these circuits and devices into various applications like wireless connectivity, Terahertz imaging, and also remote sensing. Now let's look into the first research area. As I said, this is one of the key areas for us. We are looking into novel devices and circuit technologies, which we would like to push to higher frequencies. Currently, when it comes to silicon technologies, these devices can operate even above 700 gigahertz, and that makes them quite interesting for novel applications. So mostly we are working with silicon devices, which means silicon germanium bipolar transistors or CMOS FDSOI devices, and we would like to enable them for these interesting applications. So the next research area is the wireless connectivity. As I said, we are looking for the terahertz frequency range because our future society is going to be data-driven and enabled by near instant and unlimited wireless connectivity. So we need to provide the bandwidth throughput that is required. For many of these applications, some applications are related to smart manufacturing, augmented reality, Internet of Things applications, and they demand really a wireless connectivity with edge cloud computing and distributed cloud capabilities. So our research really has the goal to inspire new wireless connectivity solutions for millimeter wave and the terahertz region. Now we base our work here again on semiconductor technologies, as I explained before, and we want to combine them with not only the circuits, but also with antennas to make them compact and mobile. Now, the third research area is related to terahertz imaging, and here we would like to basically use the terahertz region as a new window to investigate materials and come up with a unique identification of materials through some spectrometer applications. So here we like to use the radiation, for instance, for security scanners or medical imaging devices. So our research goal is to use, again, the semiconductor technologies in cameras, for instance, with real-time capabilities, but we're also looking into novel illumination techniques and the use of terahertz light fields to reconstruct 3D information of objects. Now, the last research area that I'm addressing here is remote sensing. Here we try to come up with ranging applications that are used for autonomous driving, healthcare, safety, and process automation. And our mission here is to innovate novel biosensors, for instance, that enable high resolution imaging, but also we are looking into 3D radar transceivers and material spectrometers. Now, the lab where all this happens is the IHCT lab and is well equipped with equipment for high frequency characterization on probe stations, but also in free space characterization on optical tables. We also have a very well equipped MIMO 6G communication lab where we can characterize multiple communication links in parallel. We also do our own assembly, wire bonding, of course, and we also have a clean room where we can clean and post-process assembly. Now, when it comes to the courses that we are teaching, the courses are divided in bachelor and master courses. All bachelor courses are given in German, master courses are all given in English. Now, on the bachelor level, we have a basic high-frequency course, which is called Grundlagen der Hochfrequenztechnik, GHF. And also we have an analog and digital circuits course, ADS, a high frequency systems course, and we are giving a seminar related to communication technology. On the master level, the flagship lecture here is the integrated circuits for communication, where we are teaching how to design RF and terahertz circuits. And also we have an imaging and sensing course where we go into the fundamentals of imaging technologies. Now, if you are interested in working with us on the bachelor and master level, please contact us. You can find lots of information on our website with some of the interesting topics that we are offering. Please contact the advisors. All their phone numbers, email addresses are listed there. And if you're interested, don't hesitate to send them an email. Now, this brings me to our final slide, which shows some of the collaborations that we are having. Most of our work, of course, is funded by government institutions on the European level or on the national level by the German Research Foundation. But we are also, of course, working in close collaboration with some of the major foundries in Europe, Infineon, ST Microelectronics. Also, we are working with Global Foundries and also some of the startups that we are creating here at our own university. So if you are interested, please give me a call, send me an email, and I'm happy to talk to you. Bye bye.